Okay. Let's see if this works. If you can see me, hit your boy up in the chat. Let me know. My brain is dead. Uh-oh. Oh, the stream is on in my computer in the other room. Okay, I gotta go turn that off. Hi, hold on one sec. Okay. Hello. Super chill stream today. Nothing fancy. We're gonna make some parts. We're gonna make the first parts that I've ever made, like legit, parts that I want to make on this new machine that I got. And I'll tell you about it in a sec. But just to get it all out of the way, this is a very casual stream. So we didn't. I set up like one camera, and we're just gonna, see what's up. Does it look and sound good to everyone? Are we all chilling? Ooh, train facts. That's cool. Off to a good start. Yes. All right. So I can show you the machine a little bit. There's going to be plenty more content with this. However, for the time being, you can see what's up. So it's a big old CNC machine, and I'm starting to learn how to use it. I'm not good at it yet, which is, the likelihood that we crash something or that we break a tool or that we do something wrong is pretty high. I've done it once or twice already, and I was assured by Tormach that the machine can tolerate a couple of crashes. So I think we're good. It's definitely an upgrade from the smaller mill that I had before, and I'm really excited to make some larger and more intense parts on this. Where can you get this t-shirt? Well, boy, do I have some news for you, and it's not good news. This is part of the John and Hank Green thing that they do every year called Pizzamas. So here's the shirt. So it's the thing that John and Hank Green do every year called Pizzamas, and it is, they celebrate this image of John Green with the mustache by making a bunch of merch, and then they donate all the proceeds to charity. Also, let me clean up the background a little bit. One sec. Get my whole trash can in there. They donate the proceeds to charity, and it's a super cool thing. The bummer is that you can't get this shirt. Nowhere can you get this shirt unless it's from someone else. My brain is my brain is off the rails today, so you'll have to deal with that. All right, what else? The machine can tolerate being crashed, but can the $300 probe? No, the probe cannot tolerate being crashed. I haven't done that yet. I've been very careful with the probe. All right. Well, why don't I talk about what we're going to do today? I didn't think far enough ahead, which, no surprise, I guess, to anyone. But I don't have the models to show you what I'm trying to build. You'll just have to watch me build it and see it as it progresses. But there's two things. There's a small little ring that's designed to go around one of the G8 rocket motors, the 18-second long burn motors. There's a little aluminum ring that's designed to go around there. We have to put a couple of holes in it, but that part's really easy. Then we have a slightly more complicated part that's a little bracket that goes on top of the hole, or on top of the holder, and that's going to attach some throttle mechanism stuff that I've been working on. So the first part's going to be easy. The second part will be a little bit more tricky. And before we do either of those things, we need to work on our stock material here. So I've got this stock. Try to get closer here. I've got a bunch of aluminum stock that I haphazardly cut with a circular saw, and we need to get it a little bit more flat so that we can put it in the clamp. Work holding is a big part of CNC. It's a part that I'm still learning a lot about. I'm trying to stick mostly with like a CNC vise right now, but eventually as we make more complicated parts, we'll have to think more about work holding. For now, my plan is to take this piece of stock material, just deck out the half that is mostly uneven. It's just extrusion, right? So we can pretty much count on this being flat enough to clamp against, but this isn't. So we're gonna go ahead and use what Tormach calls conversational milling. So we're not working in CAM or CAD, we're just doing like facing operations, step downs, stuff like that. We're gonna deck this off, create a flat piece of material, and then we'll work from that. Also, I need a ruler. Where did it go? I just had one. Bro, where did this ruler go? Alright, well here's a different one. So, material at its smallest is about 1.5 inches. I'm going to check that against the stock material that we have in the CAD. Yeah, and also just a heads up, the exciting part of the stream is still probably about 10-15 minutes away. But why don't we get started with this and see where it takes us. Also got some more pieces just like this. These will also have to get decked down, but we'll cross those bridges as we get there. Do I have any plans to do a liquid fueled motor in the future? Nothing immediate. I'll say the thing that I've tweeted a couple of times, which is that if you build, and by the way, don't do this if you don't have experience, but or if you don't have a mentor to work with. If you build me a tiny little liquid rocket motor between 100 and 500 pounds of thrust, like I'll fly it. I'll buy it from you and I'll fly it. But it has to have incredible reliability, and you have to like do it safely. I don't want to do the prop dev on that, and so if someone else wants to do that, I'm down to collaborate. But that is not my area of expertise. Okay. Oh, what up, Tiff? Who up CNCing? Me! All right. Why don't we get started? So, let me make sure you can like see what's going on here. So I'm gonna put this piece of metal in here. The other thing that we're gonna be using a lot of is called, they're called parallels. So I have this nice set here. Keep switching camera views. This nice set of what's called parallels, and so these are really flat pieces of material that help you move things up or down in the vise. So if I take a set of these, this is actually two right in here. Oh boy. Okay. So these are, what is it, 1/8 thick by 3/4 inch tall by 4. And they're identical. They're like the same piece of material basically. And what you can do is in here, when you get into the CNC vise, you use the parallels to elevate the material so that you have a flat reference surface within the vise. That means you don't have to go as low as you would before. If that makes sense. Okay. So that's pretty good. Oh, also, check this out. I don't know if Tormach's going to be stoked about this. Like, I'm definitely working with them as like a deal with this machine. But look what I did. So I took all the LEDs, or I took a bunch of the LEDs from the Christmas tree, not quite all of them, and I put them in the CNC. So like, it's a bit of a party in there, and I'm stoked about it. There's like some great modes in here though. Stars is pretty cool. It's the gamer CNC, dude. There's one in here that's like very pretty. That one, I like that one a lot. It's not very bright, but it is really cool. So let's keep that on for a hot minute. Okay, so now, that's in there. Who up cranking down the vise? Oh wait, before I do that, the other thing I want to do is give it a little whack. There we go. Okay. So we can count on that being secure now. We're also going to change out our tool to something larger. We could use the Superfly if it is set up in here, but I think I'd rather not. So we're going to use a 3/8 inch end mill here to face off the material. Okay. And then we'll just set our zeros kind of roughly. It doesn't matter exactly how tall or like how much we take off. What's important is that the two surfaces are parallel or close enough to it that we can successfully clamp it in the vise. Okay. Okay, so I haven't used the conversational milling thing for a hot second, so I will point the camera toward that and you can sort of like watch the process. Bro, this light just makes everything worse. There we go. Let me grab another light too, so it's not so dark in here. All right, so this is the conversational milling page, and this is going to let us, I would not bet on the lifespan of those LEDs on the mill. They are waterproof, which is cool. I'm not using flood coolant on this, but they are waterproof. That said, they are also flight proven. They did fly on the Christmas tree and slam into the desert. So like, I think, you know, we'll see how long they last. All right. Okay, so our material is aluminum, 6061. G54 is like a regular work offset. We have to choose our tool, which is going to be the 3/8 end mill. These are my tools up in the tool thing here. That was kind of a lot of work to like get that set up. It was not a thing that I was familiar with. But we have our 3/8 end mill, so that's tool number 1. So in conversational, we go with tool number 1. I don't care that it's spiral, really. Oh, rectangle, that's what I want. The RPM, it's gonna like try and set our speeds and feeds for us. Sometimes it works, and sometimes it doesn't. So right now it's 85% step over, which is kind of aggressive. So let's not. No, that's 330. That's a 35,000. No, 3,500% step over. What did I want? 1.3. There we go. 34% step over is pretty tame, and then the step down. Well, we need to set our positions first. So on X, I'm just going to go ahead and get kind of conservative with it. So we'll go a little past the material on X, which is going to be this. It doesn't matter. I guess we can zero these. Y is going to be zeroed there. And then Z is going to be zeroed here. Okay. Okay, so on X, if we start here, if I copy this number, put it at X start, that's where we're going to start. Then, going to move to the end of our material. And that's going to be the X end, which is 5.23. I'll just copy that. Then the Y start is going to be pretty much where we are. I might back it up a little bit. So like here. The step over we already set, and then the Y end is going to be here. Okay, and then finally we can set our Z. Our Z start is going to be 0. The depth of cut is 50 thou, which is probably fine. What is that? That's probably fine. We can slow it down if we need to. And then Z end, how far down do we want to go? That is kind of the question. I want to go that far down. So we have like a 1/4 inch total travel on Z. Okay, and then the clearance is fine. What do we think? We all feeling good about this? What material you're machining? It is 6061 aluminum. When someone is like, this is made of aerospace grade aluminum, it's just 6061. It's like very run of the mill. Like, yeah, it's aerospace grade, but also like, it doesn't mean it's a, you know, some crazy amazing material. It's just like, it also happens to get used in planes sometimes. I think all of the stuff that I'm doing today is 6061. I don't think I have any 7075. Okay. I think we're pretty much ready. The other thing I'm going to do is I'm going to turn on the coolant. And this is going to take a hot second. And I'll tell you why. Hold on. Now that the compressor is off, I have a fog buster on this machine. The fog buster is very cool. The only thing that I have noticed so far is that the coolant likes to recess in the tube. So if you can see the tube that's like running to the fog buster, the mister thing, it doesn't have any coolant in it. It doesn't have any, what do I have? I have like extreme cut something. I have 251C cutting and grinding fluid, and it takes a while, for it to get, moved toward the fog buster, and it doesn't stay in the line. It'll, recess a few feet in the line. So it is presumably it's coming down the line, but it's going to take a few minutes. Oh, I'm also gonna re-zero everything because I had the wrong tool in there. So I guess we have a nice opportunity to do that. Okay, X0 and X523. That's plenty. Y, actually the X and Y aren't going to change. It's the Z that needs to change. Whoops, well, that wasn't right at all. You can see the coolant coming through the line now, right? See, like right near the spindle, it's like slowly propagating up the line. That's what's going. That's what's going on. We're almost there. I'm also going to turn this off and just make it white again. It looks prettier that way. Yes, Peter's right. Sorry. So right now we're facing the material to make it flat, and then we're going to clamp it and run a whole program with a bunch of different tools that I set up to make what is basically just a ring with some holes in it. It's very exciting. And then the other thing that I said before that I'll say again is that I'm very new to this. I'm very new to this, so the chance that something goes wrong is pretty high. You know, stay tuned. One thing that I thought would be really cool is I've got this huge 3000 psi air tank that I used to use for the silo launched vehicle, and I thought it would be cool to use that as like a straight reservoir. All right, we're pretty much good here. I'll let it actually come through. You'll hear it quiet down. And there we go. Now we're getting some coolant. I was thinking that it would be cool to use that as a reservoir so we didn't have to have the compressor turning on and off for longer runs, but I don't love the idea of keeping a bunch of 3000 psi air just like chilling, and that tank is several years old. I don't know about it. All right, let's face this material. I'm going to post it to, we'll go into tests and we'll just say, face stock 1.nc, save. We're going to trust the things that it gave us. You can see right here, that's our tool path that we're going to use. And, you know, good luck. We'll see how it comes out. Are we all ready? Is everyone feeling good? I'm going to record on this. And let's hit it. Do we have anything else to do? We're on tool 1. I'll turn the coolant back on in a second. face the material. I should face your problems. Are you able to control it completely manually, or do you always have to automate it? You can do either one. You could do manual milling if you wanted, but the automated stuff is really nice. It's been easy so far. All right, 3, 2, 1, go. Now it's going to step down. We could for sure be taking deeper cuts, I think, but it's nice to just like not go nuts on the tool. Wonder what my landlord thinks. I am fortunate enough to be in a house. I will also say, this thing is way quieter than my desktop mill, which is a little funny to me. Let's see if it, I don't think it'll get it on this pass. There we go. This mill is way quieter than my desktop mill, because I think it's just, it's more, okay, minus the compressor at least, but it's a lot more rigid, right? So my desktop mill had all of these vibrations within the machine, and this thing just doesn't care. Like, the aluminum is nothing to it. And my desktop mill was sort of at its limit with aluminum. Yeah, for those who are just joining, I'm leveling out this block so that we can put it in a clamp and then make a different part with it. Almost there. You can also see you can watch it run through the G code too. So those are all of the little G code commands. One thing to note here, we're definitely not cutting fast enough, so I'm going to increase our feed rate. We're getting enough heat that I can see a little bit of smoke. Going down on the spindle speed should help a little bit too. Although it doesn't really matter because we're pretty much at the end of the program. Okay, so this looks good. Yeah, there's definitely like a little bit of smoke in there, which I don't love. All right, let's get some cleanup going here. I need like a rag. These paper towels keep ripping when I use them. All right. But this looks great, nice and flat. Good stock to work from. And then we're going to clean up all of the coolant off of it. The coolant is pretty annoying, but it does help us cut. Here are the parallels that we used as well. Put those back in the box. Actually, I should clean those off first. One and two. Oh, a paintbrush. That is a good idea for the chips. That's a great idea. Yeah, so here's our block. Flat enough. Should work fine in the vise. Right, and what we want to do is mount this so that it sits fairly proud. I wonder if that's high enough. Not quite. This is probably too high. Okay. This is good. Yeah. All right. Who is... All right. So one thing I need to check here is what our stock material was planned to be, because this is larger than our stock is planned to be. I will be right back. I'm going to check what that looks like, and then once we do that, we can set our zeros and start milling. Okay, I think I may have some good news and some bad news. This is supposed to be 2.5 inches, and it is 1.5. So we're gonna have to flatten out another piece of material. Yay! All right, we have more flattening to do, and the bad news is that it may be a little harder than the first one because this has two surfaces which are not flat. So we have to like define, all right, so we can use this piece of material that we just flattened out later on for the other part, but for this first ring, it has to be larger. So I have a bigger piece of stock that we can use. These things were gonna need to happen anyway, but we're just starting off a little bit more boring. So how are we gonna do this is the question. It's gonna be kind of janky, I think. Like, I think we're gonna sort of pseudo-define a flat surface up here and then use that as a reference to get one on the other side. Boy, this is sketchy. But we're pretty much doing the same thing though. We're gonna like face it off, and then I'm just gonna change the RPM. We're gonna go down to like 6,500. And maybe step over a little bit more. Okay, so X start. The solution to this is, of course, that you should just buy stock material that's closer to the right size. I'm working from a bunch of stuff that I've had for like a few years, and I'm trying to like eat through that before I buy new stock. All right, that's our X start. We're just gonna say X start is 0. Then is it long enough to do that? All right, that's going to be our X end, which is 6.82. 6.82. Y start is probably going to be the same, right? Yeah, that's going to be Y start. Well, actually, .9. .09. Yeah, so we can keep our Y start, and then we just have to change the Z. And that's going to reference the top here. So that's about the highest point. That's our Z top. Z0 on tool 1. And then the bottom, lowest point is probably like here. So we're going to do whatever this is, so 0.8, negative 0.1. Okay, that should be an easy little program there. So we've got our X start, our Y start, pretty much the same all around. Maybe I'll go a little faster. 6,700. Post. We're gonna call this, we're gonna replace face stock one, overwrite. Okay. Well, oh yeah, the coolant is flowing back, isn't it? We'll turn it on now. Let's do it again. So same thing as before, we're just flattening out stock. And then only one more pass to go here, which seems unlikely, but we'll see if that works. We have a little nick in the edge of it there, but that's fine. And that's it. So now we're going to do the other side. Open this up. Let's open up this pit. All right. It's a choice to watch this stream. You choose this content. I go up, over. Before we do that, I'm going to clean it off a little bit. The surface finish is really beautiful. It's like very, very pretty. All right, but now, the great thing about what we just did is that we can use this surface to face off this side and make it totally parallel. Oh, I didn't knock it down, did I? Okay, so all we need to do here is double check our X, Y, and Z zeros, and then we'll be Gucci. So in conversational, go back here and say that this is probably Z0. We'll call that 0, and we're going to step down 2. That's fine. Okay, X start is 0. So let's, whoops, skipped a step there. I should double check. Your boy collided with the machine, or the stock a little bit. All right, we'll reset that. There we go. So X is going to start at 0, which, no, it's not. It's going to start here, -3. Okay, and then X end is going to be here, which is 6.4. Let's go 6.5. Y start and Y end will be the exact same. So let's post face stock 1, save, overwrite, main, file, load G code, and I think let's send it. I did not deburr the part. I am sorry. I should have deburred the part. It's a nice thick cut. Oh, maybe it's me that you can see. Maybe it's not that much smoke, but I keep seeing myself in the reflection. Okay. Oh, it's a little hot in here. All right. Same thing. Clean off the part. And now we can finally make something instead of just, instead of just messing around and facing off parts. We can actually make something now. Let me clean this off a little bit more. Can I make this spray different? There we go. That's what I want. Okay. let's get this open. Get all that coolant off. How are we feeling? How's everyone doing? Look how nice this looks. It's very pretty. Okay, so we had these parallels somewhere, and I lost them. Here they are. Oh, is that? Oh man, we are right at the limit of the vise, just with the jaws that I have in there. Okay. So, nice and clamped. We could use the probe to set distances, but I kind of don't want to do that. Maybe we should. I think maybe we should. The probe is also fun. So let's do it. Okay, so in our probe, we're going to say find Z minus and set work origin. Oh, we have to change to tool 99. Okay, we're in tool 99. Okay. So that's our Z0. We can, I guess we can set zeros this way as well. Yeah, screw it. We can just do all the zeros since we have the probe there. Okay, so now we're going to find x plus and set 0. Sort of see what's going on. I'll do it one more time. But the probe touches the side of the material, and as soon as it gets a response, it sets that as the 0. So now we'll do it with this edge as well. Probe y plus, set work origin. And so now we've set our work origin like at this corner pretty much. Yeah, so x and y are both very close to 0, and then z is about a 1/4 inch above the stock. So we've probed it on all 3 axes. We have our zeros set relative to the work piece. This keeps dripping. Now we can change to our first tool. So the first thing we're going to do is go into File, Back, 29mm throttle, and then heat ring full sequence. Load G code. And our first tool is going to be, oh, we don't even use T1. That's cool. So I can dust this off and put it away. So our first tool here is a 1/4" end mill. 1/4" flat, I guess. And then one thing that I want to do when we switch to this tool, I'll go ahead and change it in my tool library. It's the 1/4" flat. It's tool number 2. Okay, so now it knows the tool length in here, and if I go down, so that should be pretty much 0. Yep, we're 8 thou above the part right now, according to the machine. So the machine knows the tool length very well. I'll go ahead and move this. The machine knows the tool length pretty well, which means that as we change tools, it remembers the offsets that each one has. Okay. That's not a very good 0 since that's an unmachined surface, but I don't think it matters in this case. Yep, correct, right? So like the edge of this stock is not, it's an extrusion, right? So it's got these ridges on it. So we're actually picking up one of those ridges probably, which means that we're not getting a super accurate 0 on that side. But I don't really care because we're just machining it out of this like very ample stock material. One thing that I am going to check is I want to look at the actual stock because it thinks that we have less stock than we do. Oh, I guess it thinks that we have 2.5. Let me go look at the cam simulation one more time before we run this thing, because just in case, you know, small chance that something goes wrong, I want to make sure we don't hit the CNC vise and that the amount of stock and the way that we're mounting the stock is not a problem. Okay, one sec. Check it out, by the way. Turning up. Got me a Seltzy boy. It's just seltzer. Gotta stay hydrated. All right, so this should be fine. It thinks we're working with 2.5 inches of stock material in this direction, and then we just have some like tame lead in and lead out. So we're gonna sort of stop cutting here, but it thinks that the stock stops here, which is not actually true, but it should be fine, question mark. We will see. Are we ready? Is everyone chilling? So we've got our zeros set. We'll turn our coolant on really quick. Give us a spot of coolant down there. But also we need to get our coolant through the lines because it's backed up a little bit. I'm gonna reload the program. I changed one thing in the facing operation, but it should be minor. I can show you what it looks like, by the way, while that's happening. Okay, turn that coolant off for a second. So this is what we've got. We've got a facing operation, and then we've got a couple of different contours to get that ring all set up. That's what we're making right here. You can see we have 4 drilling operations. There's one entry point for the contours, but then there's 4 drilling operations. We're doing M2 holes, and then we're going to tap them later. And then we finish it out, and you can see we also leave tabs that we're going to have to Dremel off after the fact. How do I move around? There we go. You've got tabs that we're going to leave near the bottom of the part so that the part should stay within the piece until I Dremel it out or just like hit it out with a hammer or something like that. Tabs are great. Big fan of tabs, especially on like small batch stuff. I'm talking as if I machine a lot. I just think they're cool. All right. Are we ready? Put it in the chat. Y'all ready? I think we're chilling. Oh, it's Joey Murphy. Wish I had a cam simulator. What a cool guy. Cam is great, dude. All right. The Joe urge to carbonate beverages. How is Phineas going? Phineas is probably not going to fly for a hot minute. I want to focus on some other stuff for a little while. Aero control got hands, dude. I mean, aerodynamic control got hands. Okay, ready? Let's do it. I'm gonna roll. And we're gonna start. Got my hand on the E-stop. Looks good so far. swap the battery. Workpiece looks moist. Thank you, Mark. Thank you for that comment. It does, to be fair. Oh, alright, well, we're not gonna quite get everything off the workpiece. So now we've got our first contouring operation. We're gonna go through the center of the hole. I kind of guessed on feeds and speeds here, so this may be a little bit tame. I think there's a little smoke, but it feels pretty good. We could probably go a little bit more aggressive. I just really don't want to break tools, man. Yeah, like the chips are all very small here. We have one more pass on this center contouring operation, so this one should break through. Did it? Oh no, this is our second to last pass. We have one more pass after this. That should have broken through. I'm gonna stop this and then redo, yeah. I'm gonna redo this in the cam so that we definitely break through, because I think I don't have a high enough tolerance, or like a high enough below the aluminum clear distance. It's probably just a couple thou there. But yeah, this is 1/2 inch aluminum. We should have gone through, and we didn't quite. So the Z probe was a little bit off. I'm gonna go fix that. It's like literally, it's like not a big problem. I'm gonna go fix that. It's just 1 or 2 numbers that I'll have to change, and then we'll come back, try to start the operation again, and then see if we can finish it without any other problems. Let's try this again. 2 small edits on 2 operations, both of them contours, and that should be a pretty simple fix here. So the only thing that we're going to have to do that's a little tricky is we're going to start this program like halfway through. So I'm going to go ahead and look. There's the facing operation. Facing is pretty simple. Okay, then we have the adaptive, and I'm going to try and start the adaptive partway through. All right, we're gonna start at this line. It's gonna be a little sketchy. Can I get some claws up in the chat, please? I would like some claws up, please, because I will need them a little bit. We're also gonna clear some of these chips out while we have the chance. Yes, please, claws up in the chat. We're gonna need it just a little bit. We're starting halfway through the adaptive, which means it might work, and also it might crash. All right, ready? All right, cool, that's great. So we're cutting away a layer that has already been cut. And then soon we will go down to another layer that has probably also already been cut. But that's fine. Thank you for the claws up. Very many claws. The Santa Claus. Thanks, Joey. probably cutting material that doesn't exist anymore. But better to be a little bit conservative with how we re-enter the program. Plenty of coolant in there. The air chips are breaking quite nicely. If I were a real machine shop, this would be very annoying. But I am not, so I don't really care. All right, this one should start cutting. Oh, there it is. Nice. All right, well, we're gonna cut a little bit more air. I was really close. Okay, very nice. Now we have a tool change. Drill 2 is what we're looking for. Actually, we can probably just keep this here. Are we spot drilling now? N30. Oh, tool 7. Uh-oh. Okay. I need to get a, I need to get a more up-to-date list of my tools, but tool 7 is the spot drill, so we're gonna do that. First, let's clean off some chips. Get this out. Uh-oh. Might need to be adjusted. There we go. Sometimes it binds a little bit. I've got the power drawbar on like very close to not releasing because one time I had it slip. All right. This is the spot drill. Okay. Also, hold on 1 second. Okay. So now we're going to spot drill. Let's do it. It stopped the program. It asked me to change the tool. I did that, and here we go. Yes, insert spot drill. Very exciting. And then we're going to change one more tool. Insert the T5 end mill, which is the 1/8 inch. I can double check that. T5. Oh, that's the 16th inch. Oh, right, because we're boring out the holes. Okay, this one might break the tool on this. Yeah, I actually kind of feel like high chance we break the tool on this. All right, so this is a 16th inch end mill. We're gonna drill out these tiny little holes here. Good luck. Okay, well, I hit my my coolant. My bad. Now we're going to T3, which is the 1/8 inch flat end mill, right? Yeah, 1/8 inch flat. I love that the fog buster just plows into the thing. Barbaric treatment of an end mill. All right, so now 1/8 inch. And we'll go ahead. So we have a couple of lines that we're trying to contour here, and then we're going to switch tools again. We're going to go back to the spot drill, and then we're going to chamfer some edges before we come back and clean up the contour. I'm actually dumb. There we go. Now we've got coolant going the right places. Okay, now we need to change the tool. Ooh, we've got some like little spindly guys. I think with all of these tool paths, we could be going more aggressive. Okay, spot drill. All right. Let me change the camera angle a little bit. So what we're gonna do, if I can get this in the right place, is come down with the spot drill, chamfer around the edge, and then we're gonna come clean up the rest of the contour. Okay, we swapped out, we're back to the 1/8 inch end mill, and now we're gonna finish out the contour. And we're starting by machining air, because I didn't want to plow into the material, and I wanted it to be like an easy start. Oh, the fog festival. Jared, I just saw your message. Yes, it is for a G8 motor. Chip evacuation in these deep contours is like not amazing, but sometimes like that it do be. Oh yeah, okay, so you can see it starting to jump up and down now. We're machining out the tabs. So we have 3 tabs around the circumference so that we hold the part in and it never drops out of the machine. Because when it does that, sometimes you can bind up. So we probably cut through on this next one. Yeah, we did cut through. And then we have one more after. I don't really think we're cutting anything on this pass. Other than just like recutting chips. All right, all done. Let me clean this up a little bit. Man, shout out white balance changing. Yeah, let's clean this up. Connecting an air hose to the compressor I have would be a smart idea. This looks pretty good, dude. Yeah, this looks great. So that's what we were looking for. We've got 3 tabs in the back. Let me clean this up a little bit more. And then we have one more part to make here. We actually have 2, depending on how that one part goes. Yeah, so we've got this ring. This is going to go around the motor, and then we have mount points for these brackets that go in front of the motor. And then these are the tabs that still hold the part on. And let me grab the motor and I can just like show you what's up here. All right, so this, the G8 goes right through this, and it's not quite, oh, it's a perfect fit. Yes, all right. Shout out GD&T, dude. That is a really good fit, actually. Yeah, so the motor goes right through there, and that helps us hold some gear in front of the nozzle. Wow, yeah. Man. Good job me on the fit, dude. Anyway, all right, great. So let's make the next part now. I'm not going to take this out with a Dremel just yet. It's not really needed. Let's see. What rocket is this motor for? This is for a bunch of things, actually. A future iteration of Scout could use it, although Scout can get away with 3D printing the components. The reason that this piece is metal is that it burns so long. Like the G8 burns forever. And that means that PLA, 3D printed plastic, is not going to cut it for parts that are flight critical and attached to a long burning motor. If you smell what I'm stepping in. All right, the next thing can be machined out of this tiny one that we faced at the very beginning of the stream. So let me double check some stuff in our cam. In our Cam Humphreys. Not like that, but let me double check some stuff, and then once we make sure that's good, we can get rolling on a different part. All right, pals. I feel pretty good about it. I posted a slightly updated version, and so we will load that. And I can show you what we're working with here. This one might take a long time. So here's what's happening. We've got this very kind of intense 3D adaptive thing going on for this bracket. And I do not think this is an efficient way to do it, but I needed to get the toolpath done. So that's what I did. Shouts out getting the toolpath done. Am I right, fellas? All right. That's what we're working with. Let me clean off the vise. I'm gonna mount this pretty much the same as the other one because it's also getting cut out of 1/2 inch. Okay. And we're going to probe off of the same type of coordinates. Okay, here we go. Need a bigger table here. That feels pretty good. All right, we're going to do the same thing as before with the probing. All right. We're going to go roughly to the middle of the material, and we're going to say probe -Z. Oh, change to tool 99. Probe Z minus. Oh, little squeak. Get nice and close on this. Okay, probe X plus. And then probe Y plus. All right, bless. Let's get the probe out of there. And I think we're starting off with the 1/4 inch bit. You can check in the thing. Face 2 flute, no, face 3, tool 2, which is the 1/4 inch bit. How are we all feeling? Does anyone have any questions? Okay. I am... this. All right. Yeah, does anyone have any questions? What are your credit card details? Yeah, I can give you my credit card info. If you give me your credit card info first, I'll give you mine. What general speeds and feeds are you using for your tools? So what's your social security number? How do you get a smooth surface after you cut your pieces with the Dremel? That one is easy. I just sand, filing and sanding, get a nice little kit of files, and then kind of eyeball it. I wouldn't put tabs on something that had to be like critically dimensioned, but the tabs for anything that I'm building here don't need to be exact. Like the way that the places I've placed them, it doesn't matter if there's a little bump there. What general speeds and feeds are you using for your tools? So, yeah, I found a bunch all over the place. Some of them are actually taken over from the Nomad for super conservative stuff on like those really small bits where I'm worried about breaking them. Winston Moy has a great channel full of speeds and feeds for the Nomad CNC stuff. Then NYCNC on YouTube is a total goldmine of content for CNC. They sell like speeds and feeds templates that I did use, because I mean part of it is it's easier to get started than just like trying to cook up your own, but also I wanted to support them because I have watched maybe every video on their channel by now. Let's see, what else? There are some online calculators you can use. I actually feel like I don't have like anything optimal in terms of speeds and feeds. I just don't want to break bits, and I don't want to be too shallow. Like there's a range of speeds and feeds that will work for any tool, and I'm somewhere in that range. Okay. When did you get a Tormach? I got it a couple of weeks ago. I'm gonna make a video about it for the Tormach channel, and I'm really excited. This is a tool that I have to grow into. It's not one that I know how to use super well, and I'm really excited to, like I have ideas for parts that I couldn't make on any other machine. Okay. Let's see, how do you look so cool in those safety glasses? It's because I'm built different. No, it's because they're great safety glasses. No Cry is what they're called. I don't know if I would have bought them if I knew that they were called No Cry. Are you self-taught? In most things, yeah. What was the name of my first pet? That feels like a security question, so I'm not going to answer that. What's the process when you need them to be dimensionally accurate? I don't know. Maybe fixturing in a second like work holding setup, and then you can just contour away the thing. I don't know. I would try to avoid it. Let's see. Are you still using 90mm rocket fuselage, and are you still using thrust vectoring? In some of my rockets, yes, and in some of my rockets, yes. What's your next project? Well, I have a video on the BPS channel coming out probably in a week or so about throttle control for solid motors. That's what we're making right now. This might be part of that video. This might be part of a follow-on video. And then after that, we're doing a very large model. Patrons know, don't say it. We're doing a very large model that's going to take a long time to build, but it's going to be very cool and topically relevant, and I'll let you guess as to what that is. Let's see. All right, well, let's start and get this show on the road. Get this back here. So the first thing we've got going on is a facing operation with the 1/4" end mill. Let's double check our zeros. So this is about 0, on each one. And that's a little bit above 0.1. Okay, so our 0 is off. Huh. I wonder if the tool pulled out. Let's try this. That looks really flat. So our tool dimensions are just a little off. I'm gonna re-zero by eye then. And we have clearance to mess with that, so I think this is fine. Yeah. Oh, because we're on tool 99. That's why. Oof. So right now we're on tool 2. Let's change that. And now, oh yeah, okay, so now we're 40 thou up, or 4 thou up. That makes a lot more sense. Gotta check those tools, homies. I do have an engine test bed, John. There's a video called Rocket Motor Test Stand on the channel that shows me building it. It's literally just a bunch of 80/20 that's put together with a couple of load cells. It has been so helpful to have something like that, by the way. I recommend it. All right, we are gonna start this operation. Is everyone ready? Claws up in the chat if you're ready. Hit me up with those claws up. How many broken flutes since stream start? 0. I'm getting better. All right, we got claws up in the chat. I think it's time to start. We're gonna turn the coolant on a little bit first because it recessed back in the line. Whoopsies. We gotta give this a minute to get toward the fog buster. Man, I'm really pleased with how nicely this came out. Looks great. All right, is everyone ready? Now we can be ready to rumble here. Coolant is pretty much ready. Going well so far. Okay, time for a cheeky tool change. What does it want? T3. That's the 1/8 inch end mill. All right, good luck. Oh, that wasn't really supposed to happen. Oh, you know what? I'm gonna hit the vise. I'm gonna hit the vise. Give me a minute. Hold on. I'm gonna hit the vise if I continue on this path. So let me go ahead, change a couple of things in the cam, and make sure that I don't hit the vise, because I don't want to do that. Ooh. Oh, I hate this. Okay. This might take a few minutes. Yeah, this might take a few minutes. I'm gonna put it back on rainbow, and you guys can enjoy the rainbow. Yeah, I have to change a little bit about how the... Ooh. Okay, I'll be back. I'll be back in a little bit. Don't go away. Okay, I fixed it. That was a lot easier than I thought. I'm machining away too much stuff with the adaptive, and I fixed it. So all we're gonna do here is start a little bit through the G code. All right, that's gonna be our set start. We're gonna go to cycle start, and it's gonna ask us to change the end mill. All right, great, well, let's get this a little higher up. Get nice and close. All right, everyone ready? I'm gonna try this again. Insert T2. Why are we inserting T2? T2 is the 1/4 inch. I'm gonna trust that this is wrong and gonna prompt me for T3. 1 second. Yes, okay, there's T3. All right, ready? For real now. There we go. Okay, well, good news. I think I created the least efficient tool path I possibly could have. I'm not sure what the plan is between, like, why it's going back and forth so much. I think we're just gonna let it do its thing. What part is this for? Asks someone. So this is a bracket that attaches to this thing, and this little circle attaches to a G8 rocket motor, and this little bracket combined with this little circle and a few other parts are going to let us throttle that motor. There's going to be a video out on the BPS channel in probably about a week about how this all works. It's going to be really cool. It's going pretty well. I'm gonna change the camera angle. We'll go with the white lights for a little bit. Apart from like the inefficiencies in the toolpath, I'm really stoked with how successful this has been so far. I feel like I don't have a great track record with CNC, and this feels great. I love the lights. I don't know that they totally translate in the video, but I think they're great. This one's called Fire. Maybe, okay, all right, well, okay, bit of an epilepsy warning on that one. But they're definitely, like, we've definitely got the gamer LEDs here. I showed this one before. This one's one of my favorite, though. It's just very sparkly. Great. Yes, my track record with CNC is a little plungy. All right, almost done with the adaptive. We have like 2 more passes to go there, and then we'll be all set. Man, it's really fun when this stuff works. I feel like it doesn't usually work because I don't put in enough effort, or the machine is, you know, not happy with me or something, but it's really fun when it works. We're a little over halfway through the program here. And then the other thing that we have coming up next, I think this is next, is we've got some spot drills. We have some boring operations to go all the way through the part for some screw holes. And then finally we have a parallel operation. And that's gonna like really smooth out the actual geometry of the part pretty well with like a very small step over. That one's gonna take a long time, but it's gonna make the part look nicer. I'm gonna try to clear some of this stuff out. I don't know why my camera, it'll record for like a little bit and then it stops. I don't know what's going on there. Oh, it's because there's low power. That's what's happening. I gotta change the battery. Luckily, aha! Very lucky. Okay, so I need to change the camera battery. I will be right back and take care of that. All right. Stand by. Off. And coming back on. See how that looks. Okay, we back. So the next thing to do is the spot drill. These are gonna be pretty easy operations. What am I reflecting against here? Huh, okay. Well, let's put the spot drill in. Let's also get rid of all of the gunk on there. So the bracket is starting to take shape. I sort of haphazardly put together this adaptive path. So like, it's a little messy. It's not perfect. Okay, spot drill. All right, ready? Spot drill time. Let's wait for the compressor. This one's going to be real simple. I'm going to leave it super zoomed in, and you'll just get to see it happen. 3, 2, 1, start. Oh, we can move this too. There's one. Perfect. Now we need to bore these out. We're going to get the 16th end mill. T5. 4, 5. Let me just double check. T5 is correct. T5 is the 16th. Okay. Great. Everyone ready? Excellent. Who's next? T4. I think that's the parallel. Okay. So T4 is interesting because it's a ball nose end mill. And what we're going to do is we're going to like trace out a path across this entire bracket to try to get it to look nice. I have done this once. It took a long time, but it did make the part look nice. The same is true for this one. Everybody ready? Let me confirm that T4 is the ball. Yes. Okay. That's a little sporty. The step over on this is pretty small. I probably should have gone smaller though. I think we're doing like a 10 thou step over. And especially for such a small part, we probably should have gone lower. It does look nice though. And we're almost done with the whole operation. Okay, nice. Next up, what are we doing? We've got T3, which is the 1/8" flatman mill. And then this is our contouring operation. So we're cutting everything out. I don't think we have anything after this. Our part is coming together pretty nice. The parallel gives it some cool ridges. All right, well, let's get the log buster set up. And we'll get to contouring. Not the makeup kind, but the CNC kind. All right, everybody ready? Rolling, T3, start. And then this is where the bracket like actually shows up as a part. We do all of these operations before the contour because the contour is going to really weaken the hold that the part, or like, you want to mill out the center stuff first so that it's really rigid in the center. And then after you mill out the center stuff and all of the fine details, then you can contour it out and like cut the part out. Yeah, the bracket is coming together. Yeah, we definitely cut through. And that's it. Let's get that stuff away. All right, so not perfect. It could use some like deburring, TBH. That can all be done by hand, but that looks pretty good. Like that's about what I was looking for. There's the bracket, you can see it there. And then I'll take it out of the vise so you can get a better look. Chips everywhere. There's a lot on the back too. clean this up. Well, it's a little messy. But it worked, so let's take a look here. So this is the part. It came out all right. It needs a decent amount of like deburring. You can see the tabs and where I placed them there. You can see the parallel path, right? It's got these like cheeky ridges on it. We could get rid of those a little bit more if we wanted. It's pretty good. Yes, so let me move the camera. So we've got this part and this part. This bracket attaches to this thing. We actually need to make a second one of these, but I have to scoot. So it has been lovely CNCing with you all. I cannot believe we didn't break a bit. That is super confidence inspiring, and I'm sure my luck will absolutely hold up in the future. I never get myself into trouble when I get overconfident. All right, well, why the curvature instead of flat surfaces, which are much easier to machine? Why the curvature? Which curvature? For the parallel, the toolpath on that bracket was a very haphazard, like, all right, this will get us close enough. So it could probably use a lot of optimization. Like there are a bunch of flat surfaces that we should have faced off and then just adapted away like the curvy parts. But c'est la vie. And it looks like the important parts that are like mechanical are all pretty much chilling. So that's good. Yeah, on the top of the part. Well, live and learn, huh? Where can I send you an engine design? I don't want an engine design, but thank you, John. I am chilling without doing any prop dev on my own, though I appreciate it. Let's see, yeah, an extra hose for the compressor would be probably the right way to do it. If I can split that off and just get a little air hose, that would be great. Who wants the carbonated milk to be an annual event? The carbonated milk is a great meme, but it can just stand on its own. Like, not every movie needs a sequel. Not every banger of a video needs a follow-up. I think the carbonated milk it's good on its own. What else? What will I do with the scrap metal? Well, you can recycle the scrap metal. You can also make smaller parts out of it, too. I haven't decided. Let's see. Usually you make right angles because cutting curves on the z-axis is not easy. Yeah, I made curves because I just wanted more material on it, and so I made the curve. I don't know. It looks nicer too. The right angles are like kind of cool, but hashtag stress concentration too. Any other questions before I peace out here? I can scroll up and see if I can find any that I missed. What is this part for? It is a throttle mechanism part. You will see more on the BPS channel in a few days, but for now, just know that for the most part, the throttle mechanism stuff doesn't have to absorb a bunch of heat. But when the motor burns for 18 seconds, it does have to deal with a lot of heat. And that's tricky. I hate imperial units. Yes, so as I get older, as I become more experienced, imperial units are a necessary thing if you're going to do any engineering in the US. Metric is also a necessary thing if you're going to do any engineering anywhere. And you just kind of have to, like, the older I get, the more I'm like, yep, you gotta be friends with them both. You can't, I think metric is way better, but that's not going to change in my lifetime, or meaningfully at least. There's a whole generation of people in the US who use imperial, and so for me getting started in CNC, like, I'm designing all of my stuff with a little bit of imperial in mind, but most of my stuff is designed in metric, and then for machining it, I machine it in imperial. I know that sounds batshit, but like, it's a lot easier because there's a ton of content online about people who are machining in imperial, and it's way easier to conform to that than it is to try and like pave my own path with metric speeds and feeds if I'm working on a machine that sort of wants to be an imperial. Let's see. Is that long hole throttle? I don't know what that means. Sorry. It does sound batshit crazy. Yeah, man. Have you ever seen that XKCD comment that's like, we look at all these standards, we need one unified, like, it's like there are 15 internationally recognized standards, and then someone goes, we need one unified standard, and then the comment goes, there are 16 internationally recognized standards. It's that kind of thing. Oh, hi, TJ. I will never say aluminium. It's aluminum. Aluminum. You're messing with my head. All right, well, I'm going to sign off. It's been lovely, folks. I might do a few more of these streams, and keep your eyes posted, keep your eyes peeled to the BPS channel in the next week or so. We're going to start with the content for 2022. Man, my brain not working today. All right, well, it's been chill. I'm going to sign off. Thanks for joining, everyone. I'll see y'all soon. Bye.